Hi, this session is on correlation coefficient, and the subject matter under correlation coefficient is how to calculate Karl Pearson's correlation coefficient by shortcut method. I'll recall our last two lectures on correlation coefficient. We had discussed two cases first, when means were in whole number. So we used our basic formula. Second, when means were not in whole number, we used a reduced or alternate formula, right? Now the question is where to apply the shortcut method. Shortcut method can be applied for either of the cases, means whether means are in whole numbers or not, it does not create a problem in the application of shortcut method. Shortcut method is applied to reduce the calculation and simultaneously to reduce the chances of occurrence of error, right? Now one thumb rule goes like use shortcut method in such situations or such problem where the values are large, right? But that is not the it's not the ideal case, right? Shortcut method can be used for any type of value, whether it is large or whether it is small. So purposefully I have chosen a small data so that I can validate even shortcut method can be used for small data as well, right? But preferably it is used for large values in real-time situation when the calculation needs to be generated very fast. We usually use shortcut method irrespective of whether the data is small, like values are small or values are large, right? So uh, Karl Pearson's correlation coefficient, as we know, denoted by small r, and this is our formula. In our formula, few new things are appearing which was not there in our last two formulae. First is dx. Dx is actually the deviation, right? What deviation? X minus a, where a is an assumed mean, right? Similarly, dy stands for a deviation in y and defined as y minus b, where b is the assumed mean of y. So we'll take a practical case again and we'll try to solve stepwise, right? So once you get your x, try to get an assumed mean. Now the best uh, shortcut to take a value as assumed mean is select the center value, right? So 1, 2, 14, right? This is the third value is the central value because we have 5 values, so third will be at middle. So I have chosen 14 as A. So I'm writing A equals to 14. Next, do the same thing for Y and choose assumed mean B from Y. So once I've chosen the middle value in X, choose middle value of Y. Right? It's not a mandatory condition that you have to choose from middle only. You can choose any arbitrary value. That can be from your data, that may not be from your data, right? But preferably we suggest to choose from your data and choose the middle value. So B equals to 7. Now we'll add few columns. So it is dx. Now we know what is dx. It is x minus a. So x is 1, a is 14. If I subtract 1 minus 14, so it is minus 13. Similarly, x is 12, a is 14, so it is minus 2. Similarly, 14 It is also 14, so it is 0. 18 minus 14, so it is 4. 20 minus 14 is 6. Right? Next thing, if we do it for dy, dy will be y minus b, right? So, see, y is 5, b is 7, so it is minus 2. 6 minus 7, so it is minus 1. 7 minus 7 is 0. 10 minus 7, so it is 3. 12 minus 7, so it is 5. Right? Now, take dx square. Dx square. So, dx square, right? Now, what is our dx? This is dx, so minus 13. You need to get minus 13 square. That means minus 13 into minus 13. Next, minus 2. So, minus 2 into minus 2. Likewise for all the values, right? Let me get it for dy, and it is dy square. So dy square. Dy is minus 2. That means minus 2 into minus 2. This is minus 1 into minus 1. Likewise for all the data. One more thing we require, that is dx dy. So here is dx, here is dy. So minus 13 into minus 2. Minus 13 into minus 2. So this is 26. Minus 2 into minus 1. So it is 2. Likewise for all the data. Correct? Now, let us start calculating. R equals to, see, R equals to n bracket n. How many observations do we have? 1, 2, 3, 4, 5. So it is 5 into, see, sigma dx dy. So we need to get sigma dx dy. We added it up. So this is 70. Right? So 5 into 70. Then minus sigma dx. This is our dx. So get the sum. So it is minus 5. Likewise, get the sum for dy as well. Right? For everything. So it is sigma dx into sigma dy. That means sigma dx is minus 5. So minus 5 into dy, sigma dy is 5. Right? Divided by. Now we have this. Square root. We have n. N was 5. N is number of information observation, right? Into dx square. This is dx square. So into 225. Right? Minus sigma dx whole square. This is our dx, sigma dx, and whole square. That means minus 5 into minus 5. Fine. Next, we even need to calculate the same thing for y. I'm just taking it off and even taking this off, right? So let us come for the next part. It is square root n. N is 5 into sigma dy square. Dy square is 39. So it is 39 minus sigma dy whole square. See, this is our sigma dy. So whole square means 5 into, right? So let us calculate. 5 into 70 is 350. And here see, minus 5 into 5 is minus 25. And outside it is minus, so it is plus 25. Right? Divided. Let me take this, put it here. Now see, it is 5 into 225. 5 into 225. So it is 1125 minus. Minus 5 into minus 5 is 25, and here it is minus, so 25. Right? Next, square root. Here it is 5 into 39. 5 into 39. Right? So it is 195 minus 5 into 5 is 25. Right. So 350 plus 25 is 375 divided by square root of 1100 into square root of 195 minus 25 is 170, right? So finally R equals to 375 divided by, see, 1100 square root. It is 33.16 into square root of 170 is 13.03. So R equals to 375 divided by 33.16 into 13.03 equals to 432.07. So if we divide, we'll get 375 divided by 432.07. It is 0.86. 0.867. On rounding off, it will be 0.87. Right? So this is our value of R. Now, as we know, we are supposed to answer three things. First is X and Y are related, as the value of R is not 0. Second, X and Y are positively related, See, the R has come with positive sign, right? By default, it is positive. Third, the degree of correlation is 0.87, right? So with minimum calculation, we can apply shortcut method to get to our result. Hope you have understood. For any further query, you can reach to me through mail by arg.86@gmail.com. Thank you.